Hello, good day. My name is Uzair Aiman Muazzam bin Sinin, 73867, from the Faculty of Mechanical Engineering, and today I will be explaining question 15 regarding solid mechanics. Now, the given question has given this diagram of a uniform body AC and a strut and also a post down here, and it's given P, the force in the middle here, is 80 kilonewtons. The diameter of AB is 40 millimeters, and diameter of CD is 80 millimeters, and it requires us to find the angle of tilt after the force is applied. Now they also gave us a stress strain graph on the right side right here. Now what are we supposed to do in the first step is we should draw the free body diagram of this uniform body right here, AC beam. So we're going to simplify the diagram into a straight line, the beam into a straight line as so. And we, pardon my drawing, we can say that this one right here will be our P, and FAB will be here. We need to remember the reaction forces should oppose the external forces because it wants to keep the beam in place. And we can also assume that this is FCD. Now how do we find what FAB is and FCD is? Well, the way we do it is we use moment or torque, where I can assume moment at A, which is positive like this, is equals to 0, right? Now when that is equals to 0, we know the length of this here is 0.75, and also right here will be the same. So we can use P times 0.75 meters, this is meters, minus, because this is the opposite of our direction right here, FCD times 1.5 meters equals to 0, and we get P 0.75P equals to 1.5 FCD, and we can see that FCD is equals to 1 over 2P. Now I can say that this is also equals to FAB. This is because both of them are in the same direction, and also P is exactly at the center of the beam, and the beam is a uniform body, so the force exerted are equal throughout the whole beam. So if I were to put the same force magnitude in the opposite side of the beam, it will be the same. So I can say that FCD is equals to half P is also equals to FAB. Now the next thing we're going to do is we're going to find the stress at the strut AB right here. Now stress is equals to F over A, so stress AB is equals to FAB equals over AAB. And since FAB equals to half P, you can put P over 2 over pi RAB squared. We can get 40 kilonewtons over pi times 0.02 squared, and we'll get 31.83 megapascal right here. Now that's stress for AB. Now for CD, stress CD, same steps, FCD over ACD. I'm going to go through this quick because it's the same. CD squared equals to 40 kilo over pi times 0.04. Am I correct? Yes, squared equals to 7.96 megapascals right here. Now since we have these two values now, we're going to need to find the elongation of the strut and the post right here. Now we need a strain for that. Now we do have a stress strain diagram, so we can use that in our advantage, where we can know that this linear part right here, which has been given values of the stress and the strain, and the equation of stress equals to the Young's modulus times the strain. Now we can find the Young's modulus by using E equals to stress over strain, and it is, I'll get the point here, 32.2 and 0.01 right here, 2.2 mega, because this is in megapascal, over 0.01, and we will get 3.22 times 10 power 9 Pascal. Excuse me, that was my cat sneezing. Now, since we have this Young's modulus right here, we can go ahead to the next step. We can find strain. Now strain from the previous equation right now will be equals to stress over Young's modulus right here. So we need to find the strain of AB over stress AB over Young's modulus, and we'll get 31.83 megas over 3.22 times 10 power 9 equals to 9.88 times 10 power negative 3, which is dimensionless. Strain is in millimeters over millimeters or meters over meters, depending on what you prefer. Now I can also find strain CD, which is the same, CD over E. We'll get 7.96 megas over 3.22 times 10 power 9, and we'll get 2.47 times 10 power negative 3. Now strain is equals to the general equation, delta L, the change of length over the original length. Now we can simplify this into delta L equals to strain times by the original length, and in that form we will find the elongation of the strut and the post. Now if we calculate it, we'll get AB right here, strain AB times by the length of AB, which is in 2 meters, equals to 0.01977 meters, or equals to 19.77 millimeters. Now for CD, instead we'll use the strain of CD times the length of CD, which is 0.5 meters, and we will get 1.235 times 10 power negative 3 meters, or more simply it's 1.235 millimeters. Now this is the tricky part right here. We need to understand what happens in this diagram just now. Now at first you need to understand that this beam is being pushed downwards. Now when it is being pushed downwards, you will know that AB will extend or will be in tension, and CD will be in compression. Am I correct? So in CD it will go lower down, and also in AB it will extend. It will be longer, and CD will be shorter. Now I'm going to draw the diagram out for you. We're going to get, okay, this is the beam itself, right? This is the beam itself, and at this point, this is CD, right? This is CD right here. We'll have to go down by 1.235 millimeters, and then the extension of AB is from here down here, right? Am I correct? And you'll get this part right here is 19.77 millimeters. Now what is this part? Because we need to understand that when it is being pushed down, the beam will look like this, and we're going to need to know the parameters right here. Now we know the length of the beam is 1500 millimeters, or 1.5 meters. Now at this point it is 19.77 millimeters minus 1.235 millimeters, which will yield you a value of 18.535. Now this value is the length of this part after the beam is being pushed down. So to find this angle right here, I'll call it theta. You need to use the trigonometric function of tangent, because you have the opposite and the adjacent. So the theta is equals to inverse of tangent of 18.535 over the length of the beam. This is in millimeters, so I convert it into millimeters. You get 0.708 degrees. So that's the final answer for the first question. Now moving on to our second question. It asks us regarding the failure, the rupture point, if I'm not mistaken, of the strut AB and the post CD. But in this case, the diameter of AB is changed to 12 millimeters, while the diameter of CD persists as 40 millimeters. Now in this part of the question, we're going to need to use this also, because everything else is the same. The diagram is the same, the length of everything is the same. The only difference is the diameter and what we're trying to find. We don't have P right now. So first and foremost, as always, we're gonna need a free body diagram of P right here, and FAB here, and FCD here. Now as you can imagine, it's exactly the same values. So I have already calculated it in the previous question. CD is equals to P over 2 right here. Now what we're going to use from this stress strain diagram is, which as you can see right here, this point is called the ultimate tensile strength point, which is the highest amount of stress that a material can undergo before undergoing necking and eventually failure. So this is the maximum stress that it can undergo before failing. Now we're going to use these values because it is given in the graph right here. Now what I'm going to do is I'm just going to use the stress equation, which is stress equals to F over A, right? Now we're going to need to find the stress of failure at A, B. So this is F fail AB over area of AB, right? Is equals to, it's the same thing right here, so P over 2 over pi. R squared is different because we're going to use 12 millimeters instead of what was it in the previous question? It was different. So the radius here is 6 times 10 power negative 3 squared, and we'll get P over 2 over 1.13 times 10 power negative 3. Now we know that this point AB, right, has this simplified equation right here. But which value are we going to use here? Is it 50 or is it 95? Now as I explained before, AB is being pulled down, so it elongates and it undergoes tensile stress, whereas CD is being compacted to a shorter amount, so it is under compression. It will get shorter. So we know that this graph tension right here is for AB and compression will be for CD. Now as I said, this is the maximum amount of stress that it can undergo before failing. We're going to use substitute this value into this right here. We'll get 50 megapascals equals to P over 2 over 1.13 times 10 power negative 3. P over 2, you will yield a value of 5654.87, and the P will be 11.31 kilonewtons. Now this is P AB, yeah? This is for AB, yeah, you can see. Whereas for CD, it's exactly the same procedure. F fail CD over area of CD equals to P over 2 over pi 0.0, what was it? I forgot, 0.02 squared, and you'll yield P over 2 over 1.26 times 10 power negative 3. And as I said before, from this diagram, this is for CD 95 megapascals. We're just going to substitute that as our value right here. P over 2 over 1.26 times 10 power negative 3 right there, which will yield P over 2 equals to 119,380.52, and P is equivalent to 387.61.04, which is also equals to 238.76 kilonewtons, the maximum amount of P before it fails. That's it. Thank you very much. Have a great day.